GCSE maths topic by topic, and today we're going to have a look at sequences. They come in all sorts of shapes and sizes, and perhaps one of the first problems you have to do is work out which sequence is which. Is it an arithmetic sequence? Is it a geometric sequence? A Fibonacci sequence? A quadratic sequence? So we get a whole load of different sequences, and our first job is to find out which is which, and then we have a go at trying to solve them. Now, of all of them, perhaps the arithmetic ones are some of the easiest ones, but first we've got to try and identify them. So let's have a look and see how we do that. If I've got a sequence of numbers, and let's just zoom in and have a look at some of those, we might have something that's really quite easy. Let's have a look at 1, 3, 5, 7, 9. We can see that this is really quite an easy sequence. We look at this and we look at what is the difference, what we're going up in. So we're going up here in 2s. So what we can easily do is we can work out what the next term is going to be simply by adding 2. Very easy to do. Now what we can do is see if we can work out a formula for this. And here we think of this number and we multiply this number by what we'll call n. Now let's see what we've got. We're going to set here n is going to equal 1. So I go 1 times 2 is 2, but what I want, unfortunately, is 1. So to get from 2 to 1 we need to take away 1 to do that, and so my sequence looks like it could be 2n minus 1. Let's try this again with n equals 2. 2 2's are 4, minus the 1 gives us 3. That seems to be right. Let's try one more for good measure, and we try 3 times 2 is 6, minus 1 is 5, and there we have our third item. So this is an arithmetic sequence, and my number here is 2n minus 1. If I was asked to find the 10th term, now I've got the formula, it's easy to work out. So what we get is 10 times 2 is 20, minus 1 is going to give us 19. And there we've got ways of working out various things with terms. So we can work out here what is the common difference between the numbers, so we can work out what the next is going to be, or we can work out what the nth term is going to be, and we can substitute numbers in there. Okay, well, that's all right. Let's go and have a look at perhaps a different sequence, because they're not all going to be this simple. So let's try one that's just a little bit harder. 3, 9, 15, 21. Let's work out first of all our common difference. So it would appear to be 6. So with just these numbers I can see this is going to be 6n. Let's set n equaling 1. 1 times 6 is 6, but I want 3, so I need to take off from my 6 3 to get down to 3. Let's try n equaling 2. When n equals 2, 2 times 6 is 12, minus 3 is 9, and it fits. Let's just check once more with n equals 3. 6 3s are 18, minus 3 gives me 15. So there we are, we've got our nth term. And if I'm asked to find the 8th term, then we go simply 8 times 6 is 48, minus 3 gives me 45. So I can work out any particular term once I've got this nth term done. Let's look at another sequence. Let's go something like 14, 24, 34, 44. This is an easy one because we've got a difference here of 10. So this is going to be 10n. When n equals 1, 1 times 10 is 10, but I want 14, so I need to add on this time 4. Let's check to see if it's right with n equals 2. 2 times 10 is 20, plus 4, 24. And the others will work in exactly the same way. Let's have a look at a different sequence. And in this sequence, we've got our numbers going down. 12, 10, 8, 6. Our difference here is going to be minus 2. Alright, so let's choose this as minus 2n. We'll set n here to be equal to 1. So 1 times minus 2 is minus 2. But I've got to get to 12. So I think I'm going to need plus 14. Let's see what happens if n is 2. 2 times minus 2 is minus 4. Minus 4 and plus 14 gives me plus 10. So it's going to work. It's all right, but I think that might be better to write that as 14 minus 2n. I never like putting minuses at the front. And there we've got a sequence that's going down. I've got a whole series of different problems that we can look at, but they all basically follow the same format. So let's just try a couple more and see if we're happy with arithmetic sequences. So let's try another one going up. Let's try here perhaps something like 4, 11, 18 and 25. Well, let's see what we've got. So 4 to 11 is going to be 7, 11 to 18 is going to be 7, and 18 to 25 is going to be 7. So there's our common difference. It's going to be 7n. n is 1. 1 times 7 is 7. I want 4. So 7 minus 3 is going to give me 4. Let's check with n equals 2. 2 7s are 14. 14 minus 3 gives me 11. And so we've got that one correct. So those are basic arithmetic sequences. and they're not too difficult. But there are other sequences that we meet. Some of them we've just got to know what they are. Let's have a look at this one. 1, 4, 9, 16, 25. This time the sequence isn't going up a standard amount. I've got here 3, 5, 7, 9. So we have got a sequence, and this is a very special sequence because we can see, if we do this one again, we can see that this has got now a common difference of 2 if we do it the second time. This is in fact a quadratic sequence, but regardless of looking at that, I can look at these numbers and I can see that this is a square. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. This is x, or n squared. So it's not particularly nasty, but it's one that we need to be aware of, and we're going to have a look at some quadratic sequences perhaps a little bit later. Let's go and have a look at a sequence which doesn't look quite so nice. Let's look at a sequence that goes something like this. 4, 12, 36, 108. Well, if we do our common difference here, 4 to 12 is going to give me 8, 8 to 12 is going to give me 24, and I'm seeing that this isn't anything like an arithmetic sequence. But let's look at these numbers again. 4 to 12, I could multiply that by 3. 12 to 36, I could multiply that by 3. 36 to 108. If you're good enough at maths, you can see that you multiply by 3. So this is one of these different sequences here, and we can work out here that our geometric sequence here has something called a common ratio. And this common ratio, r, is going to equal here 3. Okay. Now, usually in these sorts of geometric progressions, you don't get asked to try and work out the nth term, not in the same way. Maybe we might get a slightly different one, but we need to try and work out how we're going to do this. And there is a special formula which we'll look at. Let's look at a different sequence. This one here is 24, 12, 6, and 3. What are we doing? Well, here we're going 3 to 6, I'm doubling, 6 to 12, I'm doubling, 12 to 24, I'm doubling. So I'm actually here halving it. And we can think of this either as you are dividing by 2, or you can think of it we're multiplying by a half. Or perhaps even 0.5. So our common ratio is going to be a half. How do we do one of these geometric sequences? Well, we have, first of all, our first number. We multiply that by then my common ratio, and we do that to the power of n, but it's always n minus 1. Let's have a look at this and see what we can do. Now, let's have something where we're going to try and work out one of these sequences. Let's do that. Let's start off with a number, and we're going to start off with the number 3. That's going to equal a. And my multiply factor is going to be something easy. Let's set it at 2. Let's see what numbers we could get out of this. So for my starting number, it's going to be 3. Now for my second number, this is going to be a times r, and it's going to be my second number, which is going to be here 2 minus 1. So this is going to be r to the power of 1, and that's going to give us 2. So it's going to give me 2 times 3 is 6. Let's do our next one. A times r to the 3 minus 1. This is now going to give me 3 times 2, which is times 2. So we've got 3 times 2, which is 6, times 2, which is going to give me 12. Let's make sure I can show you where the working out is. Let's do one more. A r to the 4. I'm going to work out my fourth term. We'll get a minus 1. So this is going to be 3 times 2 times 2 times 2, which is going to give me 24. This looks remarkably like that term. They are the same one, they just this time is going the other way. We can think of this though as this one's going to be a, this one's going to be a times r, this one's going to be a times r squared, this one's going to be a times r cubed, and so we can think of this as if r is 2, then we're going to multiply by 2 squared, which is 4, and then we're going to multiply by r cubed, which is going to be 8. So it's another way of trying to look at these sequences and try and work out what they are. Let's have a problem, and these problems always cause us a bit of grief. So let's try a little problem. And let me say that we might be told that my fourth term in a geometric progression equals 49. And we're told that my fifth term in this geometric progression is going to equal 245. Ugh, this looks a bit horrid, doesn't it? I wonder what we can try and do to try and solve this problem. Well, the good news is for a lot of these that a calculator can be quite helpful to try and work out what's going on. And we can use our calculator to try and do this, and it makes life quite a lot easier. We know that a of r to the and it's the fourth term, so that's going to be r cubed is going to equal 49. And I know that a r to the 4 is going to equal 245. So somehow I've multiplied this number by my common ratio to get my next number. So simply now I could divide by 245 by 49 and get my answer. Let's see what happens if we do that. 245 divided by 49, and that will give me a simple answer of 5. So my common ratio here is 5. Once I've got that, it's possible that I could actually work out what A is, or any other things that I might be asked to work out. Let's do another problem. And let's suppose the first two terms in a geometric progression are going to be something like 2 and term 2 is going to be 12. Okay, so what's our common ratio? Well, 12 divided by 2 is going to give me 6. So my common ratio is 6. Now, let's suppose we're asked to find the fifth term. If we're asked to find the fifth term of this, then a r to the power of n minus 1, so that's going to give me a r to the 4. We already know what a is. A is 2. We know what r is, which is 6 to the power of 4. So let's go across to the calculator and we can work that out. So we've got 2 times 6 to the power of, I'm using this one this time with the blank number so I can put in here a 4, and we come out with our number 2592. Geometric progressions tend to expand an awful lot, and they give us quite a lot of grief. Let's look at a couple of other numbers and see what happens in these sequences, and these aren't necessarily quite the same. I've got a sequence that goes like this: 1, 1, 2, 3, 5, 8, 13. I've given a lot more numbers here because the sequence is looking a little bit odd. Let's have a look. Our common difference here is 1, is 1, is 2, sorry, is 1, can't add up, 2, 3, 5. Now, if I look at what's going on here, these numbers are translating further along. I was thinking about that while I'm trying to do it, so I could actually predict the next one's going to be 8. And we get each number of the sequence by adding the previous two together. So 1 and 1 make 2, 1 and 2 make 3, 2 and 3 make 5, 3 and 5 make 8, and so on. This is a special sequence called a Fibonacci sequence. Let's see if we can have a look at another one of these. 2, 2, 4, 6, 10, 16. And I'm calculating that as I'm going along by putting down my first two numbers, then 2 and 2 make 4, 4 and 2 make 6, 4 and 6 make 10, 6 and 10 make 16. So 10 and 16 would give me my next number, which is 26. So we can work out what this is. We can work out a Fibonacci sequence here by simply adding the previous two numbers together. Well, none of those are really too bad, but where we start getting into difficulty is where we have a sequence that's made by, rather than anything else, something like a quadratic equation. Let's do one of these quadratic equations. Let's have 2x squared plus 3x plus 4. Now let's see if we can work out what some of these numbers are going to be. So I'm going to set x first of all equal to 1. So if x was 1, let's see what we can get with this. So 1 squared is 1, 1 times 2 is going to be 2, plus 1 times 3 is 3, plus 4. So that's going to give me 2 plus 3 is 5, and 4 make 9. So 9 is going to be my first number in my sequence. Let's try x equals 2. 2 squared is 4, 4 2's are 8, plus 2 times 3 is 6, plus 4. So here we can add them up, which is going to give me 14, 18. X is 3. 3 squared is 9, 2 9's are 18. 3 3's are 9, plus 4. So 18 plus 9 is 27, plus 4 gives me 31. And you can see that as we go along here, we're starting to get worse sums to try and work out, because trying to generate this one starting to get nasty. We've got 4 squared is 16, 2 16's are 32, plus 4 3's are 12, plus 4. So we've got 44, 48. Now, if I haven't made a mistake, this might work out as we go along. So I've got a sequence of 9, 18, 31 and 48. And what I've got to do is I've got to work out what's going on. So let's see if we can work out what's going on here. So first of all, we need to work out our common difference. 9 from 18 is 9. If we need to do then the next one, which is going to be 31 minus 18, You can do it in your head, or with many of these you've got the calculator to try and help you. So we've got 13, and then our next one we've got 48 minus 31. Gives me 17. Let's look at the second common difference. 9 from 13 is 4, 13 from 17 is 4. So we now have a second common difference. And the rule is, what we do is we halve the value. So this is going to be 2n squared. So we can work that out from the 4. Okay, so I now know my sequence is going to be 2n squared plus, most likely to be a quadratic, we know it is, so this is going to be b times n plus c, because this n squared plus, it's going to be an squared plus bn plus c is the form of a quadratic equation. Now we know this, let's see what we can do. Let's put some values in here. So I'm going to set n is equal to 1. Okay, so here we go. 1 squared is 1. 1 times 2 is going to be 2, plus b times 1 is going to give me b, plus c. And I know that from my sequence was equal to 9. Let's sort out what b plus c is going to be. So b plus c is going to be those two numbers, take the 2 over, so minus 2, 9 minus 2 is 7. Let's work out what n is when it's 2. 2 squared is 4. 4 times 2 is going to be 8, plus 2b plus c, and this equals the value of 18. So I can work out that 2b plus c equals 18 minus 8, which gives me 10. I've now got a simultaneous equation. I've got this set of values and this set of values. Let's put down this underneath, b plus c equals 7, and what I'm going to do is I'm going to take them away. So this is going to be minus b, this will be a minus c, and this will be a minus 7. Let's do this. 2b minus a b gives me a b, the c's cancel, and we get here 10 minus 7, 3. So I now know that b equals 3. Let's substitute into one of these. So I know that's the easiest one to do. So I can go 3 plus c equals 7. Take the 3 away from both sides. C equals 4. So my equation, going back to my original here, an squared plus bn plus c. My a, we've already worked out from the top, was 2, so that's going to be 2n squared. I've worked out my value of b to be plus 3n, and my value of c is 4. And I've worked out my equation, 2n plus 3n, 2n squared plus 3n plus 4. And if I go back to what we started with at the beginning, that was my equation. And so I've solved it. To recap, we solved it by working out, first of all, our common difference. We didn't get anything nice, so we tried a second common difference, and because that was a common number, we then halved that value to give me a quadratic sequence, and then I solved the rest with a simultaneous equation. Now, you don't need to use a simultaneous equation, but if you do, it will always work. And if you don't, you might get away with it, and you might not. So we've looked at arithmetic, geometric, Fibonacci, and quadratic. Are there any more types? Unfortunately, yes. So, what other sorts of numbers might we get when we're trying to play around with some of these sequences? How about this number? I've got 1, 3, 6, 10, 15. Well, let's see what we've got. We've got 1 and 3 is 2, 3 and 6 is 3, 6 and 4, 6 and 10 is 4, 10 and 15, 5. I've got the numbers going up. And yeah, we can look at this one and we can see that, yeah, here is going to be simply 1 between them. And if I halve those, then I've got 0.5 n squared. Now, this sequence here, we can imagine is something else. This here is something we call a set of triangle numbers. So we might see some of these sort of nasty sort of numbers. Now, basically, sequences based on triangle numbers go up by 1 number more each time. So as soon as we see this, we know these are triangle numbers. Now, others might go up by other nasty sequences, and we can get some of those. So sequences are not particularly nice sometimes, but there are some interesting things we can sort of pull out from them. And I just want to look at quickly something called Pascal's Triangle. We start off with the number 1, and under that I'm going to put 2 ones. I'm now going to sum up the numbers, so I'm going to put down a number 1, 1 and 1 make 2, and 1. And 1 and 2 here make 3, and 2 and 1 make 3, 1. 1, 4, 6, 4, 1. And carry on quite a way. 1, 5, 10, 10, 5, 1. And we'll do one more. 1, 6, 15, 20, 15, 6, 1. What does it mean? Well, let's take this sequence and have a look at something. And I'm going to take a little equation and I'm going to do x plus y all squared. Now what does that mean? That means, of course, it's going to be x plus y times x plus y. Let's multiply these together. So that's going to give me x squared, xy, xy again, plus y squared. Add those two up. We've got x squared plus 2xy plus y squared. Let's put some numbers in here. 1, 2, 1. 1, 2, 1. That's a number sequence in the Pascal's triangle. So this was an x squared term. Let's look at this one here. Is it an x cubed term? If it's an x cubed, then this is going to be x plus y cubed. Well, x plus y cubed is going to be the same as x plus y times x plus y times x plus y. Now I've just worked out what x plus y times x plus y is, so that's going to be x squared plus 2xy plus y squared, and that is going to be multiplied by x plus y. Let's do this. Let's multiply each one by x and then each one by y. We get x cubed. X times that is going to give me plus 2x squared y. And then I'm going to get plus xy squared. Multiplied by y. This is going to give me x squared y. This is going to give me 2xy squared. And finally I'm going to get my y cubed. Let's collect the like terms. X cubed plus, now I've got 2x squared y and I've got another x squared y, so that's going to give me 3x squared y plus, I've got a xy squared and a 2xy squared. That's going to be 3xy squared plus 3y. And I've got this 1, 3, 3, 1. And that is my other line. Just for fun, let's work out this one. But I'm going to do an awful lot of cheating here. So this is going to be x to the 6. So I'm going to have an equation which is x plus y to the 6. Now I'm going to cheat, and I know from my Pascal's triangle that the numbers are 1, 6, 15, 20, 15, 6 and 1. Now if we look at this little sequence, my x value is going x cubed, x squared, x, none of them. Oh. So let's put those in. So I could go for here x to the 6 plus, this is going to be 6x to the 5 plus 15x to the 4 plus 20x to the 3 plus 15x squared plus 6x plus, don't know. The y, what was that doing? The y was going the other way. We started with y cubed, y squared, y. So in this first one then, I could set this to be here y, y squared, y cubed, y here to the 4, y to the 5, y 6. And there I've actually written out my entire sequence, nearly enough space to get it on the page. There we are. Without having to do any working out at all. So sequences are quite good fun. They're not as hard as they seem. You have to look at sequences and see what you can do with those sequences, how to try and solve them, how to work out what you've got to do. Thank you for watching. I hope you found that one interesting. If you liked it, then please subscribe, and I'll see you again next time when we'll have a look at more maths GCSE topic by topic. Thank you. Bye bye.